With the gradual exhaustion of the IPv4 address space, new solutions for continued address space were needed, and the temporary measures in the form of NAT were applied. However, long-term solutions were required. So the IPv6 addressing architecture is a developing solution for IP to provide for the next generation of networks and beyond. The transition to an all IPv6 architecture, while progressive, requires a major overhaul of many protocols and applications as well as standards. The IPv6 network, however, aims to resolve many limitations within the current TCP/IP suite, most notably addressing the need for integrated security measures and the streamlining of protocols to minimize overhead. A deep knowledge of the IPv6 architecture is required by engineers as IPv6 continues to evolve as an integral part of the enterprise network. Okay, so upon completion of this section, you will be able to explain the characteristics of IPv6 and explain the IPv6 address format and addressing types. Describe the process for IPv6 stateless address auto-configuration. Okay, first, let's look at the most important difference between IPv4 and IPv6. We know in IPv4, we only have 32 bits used for the address size. So, the total number of addresses for the IPv4 is only 4 billion. 4 billion. So that is not enough for all the hosts, all the network devices in the world to have one IPv4 address. But for IPv6, we can see we will use 128 bits for the IP address, and this number is very big. At the beginning of the IPv6, when we produce this new version, at the beginning of the IPv6, when this version is produced, there is a saying that for IPv6, we will give every sand on the earth an IPv6 IP address. Okay, so we can see the space of IPv6 IP address is very, very huge. And the next big difference is IPv6 header format. So in this header format, IPv6 header has been streamlined to reduce the overhead. So we have removed some useless fields in the IPv4 header, and we change the address fields from 32 bits to 128 bits. Okay, and another important difference is the IPv6 address. We have the extension header. The extension headers are used to support parameters that are not required in every IP packet, such as fragmentation and IPsec. For example, this is a fragmentation extension header. Not all the IP packets, they need the fragmentation. So only when you need to fragment the packets, then you will have this extension header. Okay, next it will be the IPv6 address architecture. We know that IPv6 address, it has 128 bits, and we can divide this 128 bits to two parts. First part is the IPv6 prefix. Second part is the interface ID. So we can regard the IPv6 prefix to be the network address and the interface ID to be the host address. And the IPv6 addresses are commonly displayed in hexadecimal format, okay? Hexadecimal format, not like the IPv4 address. So we can use 8 groups, 8 sets of hexadecimal digits to describe one IPv6 address. Because the IPv6 address is too long, so we must think about a way to condense the IPv6 address. So let's look at this IPv6 address. In this address, we can see there are a lot of 0. So first we can remove all the leading zeros in each set. Okay? First, for this set, we can remove this first 30. And for this set, we can remove this first leading 30. And this also remove. After this, and also here in this set, we can also remove this leading 0. Now we have removed all the leading zeros in each set, and then we will get this IPv6 address. But we can see there are still some zeros here. There are still some zeros here. Okay, so we can use double colon. Operator to further condense the strength of 0 values. So we have some continuous 0 values. So we can further condense it to the double colon. So finally, we can get the IPv6 address like this. Okay, but remember, the double colon can only be used for one time in one IPv6 address. Only can be used for one time. So this is the IPv6 address condensing. You must be able to condense the IPv6 address from this complete address to this one. And also you must be able to read this one, to recover this condensed IPv6 address back to the original IPv6 address. Okay, next will be the IPv6 address reservation. First, the most important address range is 2000:3. So this is the current global unicast range. So this range of the addresses are used in the global network, in the internet. And next important address is this. It started with FE80, and this address is link local unicast address range. What does it mean? It means this kind of address can only be used in the local link and cannot be forwarded to the global network, cannot be forwarded to the internet. For example, we have a router, we have 2 routers, and on this link, they may have the IPv6 address. So this IPv6 address can be used only on this link local, cannot be forwarded to other network or to other router, is forbidden, only can be used locally. Okay, the next important address is multicast address. The multicast address is started with FF00. Okay, now let's look at the IPv6 addressing the unicast. So this is a kind of IPv6 global unicast address. So the first 64 bits, they are like the network address, and the first 48 bits are global routing prefix. Then the 16 bits are the subnet ID. So it's just like the network address and the subnet address. Then the rest of the 16 bits are interface ID. So the interface ID, like what I just said, is just like the host address in IPv4 address. So finally, this is a global unicast address. And this address is a link local unicast address. For the link local unicast address, the first 10 bits must be this one. So it must be started with FE. Okay, and then this 54 bits must be 0. And then the last 16 bits are the interface ID. So the interface ID will be generated by the host. And then is the multicast address. For the multicast address, the first 8 bits must be all 1. So the multicast address will be started with FF. And here we have two special multicast address range. One is FF02:1. This means all nodes addresses. And if it's :2, it means all routers addresses. And in the multicast address, we have the group ID. This group ID can indicate which group does this multicast address belong to. So we can have different multicast groups. Okay, next one is a little special. Next one is Anycast. Okay, Anycast, it means for some servers, they are providing the same services. For example, we have HTTP servers. We have 2 HTTP servers in this network. And we can configure the same unicast address. For them. So if some clients, they want to access to the server, they will find the closest server to them. So this can help us save the network resources and to make the connection faster. And also, the Anycast can help us to make the redundancy of the server. If we have 2 servers and 2 different IP addresses, when one of the server is down, we must change the IP address. On the client to access to the server. But if we use the same address for these 2 different servers, when one server is down, the other server is still up and the IP address is the same, so we don't need to change anything on the host, and they can continuous access to the server. So this is Anycast. Next, it will be the IPv6 stateless address auto configuration. One big difference between IPv4 and IPv6 is, for IPv4, if one client it wants to get an IP address automatically, we will need the DHCP. Server, and the DHCP server will allocate the IP address for the host. But in IPv6, we don't need to configure the DHCP, and we can use stateless address auto configuration. When a client is joined in this network, he will send router solicitation RS packets to this network, to the routers of this network. And when the router receives this RS, the router will send router advertisement RA packets to this client. What's the meaning of this packet? So it will tell this packet what is the prefix of this network, of this IPv6 address. So the router will tell the prefix address of this network, and the client, he will generate, or we can manually configure the interface ID for the host. So finally, it will have prefix plus the interface ID. So the host, finally, it will get his IPv6 address. So that is stateless address auto configuration. And I have said that the host, it will need the interface ID. So how do we configure the interface ID? How do we generate this interface ID? We can use the automatic way to generate the interface ID. That is the EUI64. EUI64. EUI64 means we know all the hosts, they have the MAC address, and the MAC address length is 48 bits. But the interface ID is 64 bits. 64 bits. The interface ID is 64 bits. So we need to translate from the MAC address to the interface ID. So how to do it? First, we should insert 16 bits to this MAC address between the first 24 bits and the second 24 bits. Between these 24 bits, we must insert 16 bits. And these 16 bits are FFFE. In binary, it will be 15, 1, and 1, 0. It's fixed, FFFE, okay? And then we need to change the 7 bits from 0 to 1, okay? The first 7 bits from 0 to 1, and then we insert the 16 bits between the first 24 bits and the last 24 bits. And these 16 bits are fixed to FFFE. Finally, we can get the EUI64. This is an automatic way to generate an interface ID. So the IP prefix, the prefix plus the EUI64, finally it will become the IPv6 address for this host. Okay, next is the IPv6 stateless address auto configuration DAD. DAD means duplicate address detection. So what's the meaning of this? This is used to check if there are some hosts in this network are using the same IPv6 address of this host. So after we generate the IPv6 address, we will send the NS packet to this network to ask, is this address in use? To ask if anybody is using this address. And if someone is using this address, he will reply the neighbor advertisement packet to this host to tell him, okay, I am using this address. So this host, he needs to change this IPv6 address. So this is a way to detect the duplicate address in the same network. Okay, that's all. So now let's look at two questions. First, what is the smallest condensed IPv6 value possible for the address? For this IPv6 address. Okay, remember how to condense the IPv6 address? Okay, first, we need to remove the leading 0 in each set. Okay, in this set, we must remove this first leading 0. And in this set, we remove this leading 0, this leading 0. In this set, this leading 0. And in this set, this leading 0. This set, we have one leading 0. Okay, now we finish the first step, removed the leading 0 of each set. And second, if we have the continuous 0, we still have the continuous 0. For example, this, and this. Then we can use the double colon to indicate the continuous 0. So finally, this address can be 2001 colon DB8. Okay, here, all of this we can use double colon. Okay, then this 0 has been removed. 32A. Then colon 2D70. So this is the smallest condensed IPv6 value for this IPv6 address. Okay. Second question. What is it possible for an end station to independently generate an IPv6 address? Okay, remember, how does an end station generate an IPv6 address? Okay. First, we can use stateless auto configuration, IPv6 stateless auto configuration. So first, this end station, it will get the prefix from the router in this network. And secondly, we need to generate the interface ID. For the interface ID, how to generate it? We can use the EUI64, which we will use the MAC address. We will use the MAC address to insert 16 bits between the MAC address, and then we change the first 7th 0 to 1. Then we will generate the EUI64. The EUI64 will be interface ID. So now we will have the prefix and the interface ID. So we will have the IPv6 address. The changes to the address architecture have introduced the need for routing protocols that are capable of supporting IPv6. So all of these routing protocols, they have developed the new versions to support the IPv6 network. For example, RIP protocol, we developed the RIP-NG to support IPv6 network. And OSPF, we developed OSPF version 3 to support IPv6 network. And ISIS protocol, because ISIS protocol is based on TLV, so we just need to develop the new TLV to support IPv6 network. So it's very simple for ISIS protocol. And for BGP, we developed BGP 4+ to support the IPv6 network. And this lecture, we are going to emphasize on OSPF version 3 protocol. So upon completion of this section, you will be able to describe the characteristics and operation of OSPF version 3.
configure OSPF version 3 routing protocols for IPv6. Okay, first, let's look at the OSPF version 3, the interface IP address for OSPF version 3. So this here we have 4 routers, and each of the router, they have the loopback interface, and we configure the global IP address, global IPv6 address for the loopback interface for each routers. And then the interface IP address of each routers, we will use the link local IP address. Okay, and after we enable OSPF on these 4 routers, first they will update the OSPF packet and sending to this FF02:5 to this multicast address. And this multicast address means all SPF routers address. So all the OSPF routers, they will receive the OSPF packet based on this multicast address. And next is the router ID. We know that in OSPF protocol, we will use the router ID to uniquely identify one OSPF router. And OSPF version 2 and OSPF version 3, they have the same format of router ID, but the difference is the OSPF version 3 router ID is not based on the IP address, not based on any IP address. You must configure the router ID of OSPF version 3 manually. You must manually define the OSPF version 3 router ID, and the formats are the same. Okay? And also, OSPF version 3 needs to select the DR and BDR. So how to select the DR and BDR is the same with OSPF version 2. We will use the priority. We will use the priority to select the DR and BDR. Priority 0, it means this router, it will not join the election of DR and BDR. And also, if the priorities are the same, they will use the router ID to select the DR and BDR. Okay, another difference for OSPF version 3 is OSPF version 3 operates on the principle of per link as opposed to the per network or per subnet concept used in IPv4. We know in IPv4 network, if we are running OSPF, all of these routers of this interface, they must be in the same network so that they can run OSPF successfully. But in OSPF version 3 in IPv6 network, it is based on the per link. It means if all of this interface, they are connected to the same link, so they can set up the OSPF version 3 neighbors. They don't need to be in the same network. So that is a big difference between version 3 and version 2. And another difference for OSPF version 3, we removed the authentication in OSPF version 3. So instead, we rely on the AH and ESP extension headers of IP for security. So if we want to ensure the security of OSPF version 3, we need the IPv6 extension headers. Remember that in the last lecture, we learned that for IPv6 header, we have the basic IPv6 header and we have a bunch of extension headers. Those extension headers include the authentication. If we need to use the authentication, we will add these authentication headers to the IPv6 packet. Okay, so let's continue to look at the OSPF version 3 configuration. First, on router A, we should enable the IPv6 function. Then we should enter the OSPF version 3 view. and router ID 1.1.1.1. Remember, for OSPF version 3, router ID must be configured manually, okay? Because the router ID, it will not automatically generated by any IP addresses, okay? So you must manually configure the router ID. Then next is enter the interface that we need to enable the OSPF. For example, G000. So enter this interface, and first we should enable the IPv6 function. Next, we should configure the IPv6 address for this interface. So IPv6 address FE80:1 link local. So this interface is a link local IPv6 address. This address is a link local IPv6 address. It's not a global IPv6 address. Okay, so it means this address is only available on this link, and this address cannot be sent to other networks or across the router. And next, OSPF version 3.1 area 0000. It means the process is 1 and the area ID is 0. So we configure this interface into area 0. And next, we enter the loopback 0 interface. And we enable the IPv6 function, and we configure an IPv6 address for the loopback 0. Now we configure this address. Remember, this address is started with 20. It means this address is a global IPv6 address. And then we enable the loopback 0 to OSPF version 3 process 1 and area 0. So the loopback 0 interface and G00 interface, they will be running in the same OSPF process and the same OSPF area. So on router B, the configuration is similar. After the configuration, we can use command display OSPFv3 to check the configuration. So first we can see the process is OSPF version 3, process is 1, and with router ID is 1.1.1.1. And here we can see the number of the full neighbors is 1. We only have one neighbors that is in full state. And OSPF version 3 and version 2, their states are the same. Finally, they should be enter the full state. Okay, so that is the principles of IPv6 OSPF version 3. So now let's look at one question. What is used to uniquely identify each neighboring node running OSPF version 3? Okay, so in OSPF version 2, we will use the router ID, right? But in OSPF version 3, we will still use the router ID. But one difference is, in OSPF version 3, the router ID must be configured manually. This is a big difference. Must be configured manually. It will not be generated automatically. But OSPF version 2, if you don't configure router ID, it can be generated automatically based on the loopback interface. Okay, in the last lectures, we learned that when a client wants to get an IPv6 address, we can use stateless address auto configuration to get an IPv6 address from the router. So that is one way. Now, this lecture, we will learn the other way. The other way is DHCP for IPv6, and we call it DHCP version 6. So this is a stateful address configuration way to get the IPv6 address for the client. So totally we have two ways. One way is stateless. The other way is stateful, which is DHCP version 6. And DHCP version 6 remains a client and server-based application layer protocol. However, includes a significant number of changes to align with the design aspects of IPv6. As such, DHCP version 6 stateful and stateless implementations and characteristics are explained. Okay, now we can see DHCP version 6. It also has two modes, stateful mode and stateless mode. The stateful mode means including all the parameters like IPv6 address, the DNS address, all of these parameters. The clients, they are obtained from the DHCP version 6 server. And stateless mode means the IPv6 address of the client is obtained from the router, but the DHCP version 6 server, it will only provide the DNS server address and other parameters to the client. So that is the stateless and the stateful. So upon completion of this section, you will be able to describe the features of DHCP version 6, explain the stateful and stateless behavior of DHCP version 6, successfully configure DHCP version 6 service. Okay, first, let's look at this. From this, we can see for DHCP version 6, it is based on client and server. So we have a DHCP version 6 client and a DHCP version 6 server. For the client and server, they will use the UDP port to communicate. For the client, it will use UDP port 546, and for the server, it will use the UDP port 547. And the stateful addressing, we know that if there is a router in this network, the client, it will send the RS to the router, and the router, it will send RA, router advertisement, to provide the prefix for the client. And if we are using the DHCP version 6 server, so the router, now it will send RA, and in the RA, it contains the managed and other configuring flags. If these flags are 1, it means now we will use the stateful addressing. The stateful addressing means the DHCP version 6 server, it will provide the IPv6 address and other network parameters for the client. So this is stateful addressing. Okay, and at the beginning, if the client wants to communicate with the DHCP version 6 server, it will use the link local address, the link local IPv6 address. We know the link local address cannot be sent out of this link. So on this link in this network, we will use the link local address to communicate with the server. And if the server and the client, they are not in the same link, we will need the DHCP relay agents. The DHCP relay agents only when the server and the client, they are not in the same link, they are not connected to the same link, so we will use the relay. If they are in the same link, we will not need the DHCP relay. Okay, and the DHCP version 6, it will use this multicast address to indicate all the DHCP servers and the DHCP relays address. Okay, so this is the process to assign IPv6 address. First, the client, it will send solicit packet to the server to request an IPv6 address and some parameters from the server. Then the server, it will send advertise package to the client. In the advertise package, it will contain the IPv6 address and the DNS address and other parameters. And the client may receive several advertisement packets from different servers if we have multiple servers. So the client, it will select the optimal server based on the priority of the server, and it will select the optimal server, and then it will broadcast or it will multicast the request to all the servers to tell them which server is the optimal server, and then that optimal server, it will send a reply packet to the client to inform the client that to confirm that this IPv6 address you can use is used by you, okay? And other servers, they will not send reply and their address will not be used. If we are using stateless configuration, okay, it means for the client, the IPv6 address is obtained from the router, not from the DHCP version 6 server. So now the client, it will send information request. In this information request, it will only request for the other parameters like DNS, and then the server will send reply packet to the client to tell the client what is the parameters of the DNS and others. Okay, this is DUID. DUID means DHCP server identifier. DHCP server unique identifier. So in this network, all the DHCP clients and the DHCP server, they will have one unique DUID. Okay, so how to generate this DUID? We have two ways. One way is LL, link layer address. Link layer address always is MAC address. And the other way is LLT. LLT means we use the link layer address and the timestamp to generate the DUID. So we have two ways, LL and LLT, to generate the DUID. And DUID is used to uniquely identify a DHCP client or DHCP server. Okay, now let's look at the configuration. First, this is to set the DHCP DUID. On router A, we can use command DHCP version 6 DUID LL. Remember, there are two modes, LL mode or LLT mode. So there are two formats of DUID. And then we can configure the IPv6 address pool. So on the router, the router A, it will act as the DHCP version 6 server. So on the router A, on the server, first we create the version 6 pool, name is pool 1. And we configure the address prefix 3000:/64. Then we can configure excluded address 3000:1. So this address will be excluded. Next, we configure the DNS server address 3001:1 and DNS domain name Huawei.com. So this is a pool, IPv6 pool. Next, we should enable the DHCP version 6 server. So on router A, first enable IPv6, and then DHCP enable. Next, we should enter the interface, which is connected to the client. On this interface, first enable the IPv6 function, and then configure one IPv6 address for this interface. So this address is the excluded address in the IPv6 address pool. And then DHCP version 6 server, pool 1. So we enable the DHCP version 6 function on this interface. After the configuration, we can use the command DHCP version 6 pull to check the configuration. From here, we can see the address prefix is 3000:64. And now we can see there are two in use. It means there are two addresses has been used by the client, and excluded address is 3000:1. The DNS server address is 3001:1, and the domain name is huawei.com. Okay, now let's look at two questions. First, which DUID formats are currently supported within VRP? Remember, there are two formats. One is LL, link layer, MAC address. The other one is LLT, link layer address and the timestamp. Okay, next. If the M and O bits of a router advertisement are set to 1, what action is taken by the client? Okay, if these two bits are set to 1, it means the client will use the stateful address configuration, which means the client it needs to obtain the IPv6 address and the parameters from the DHCP version 6 server. Okay.